We're going on now to continue our review for the final exam. And this is a test, Form A of Chapter 2 that I have here. And what we're going to do is feature a number of things. If we didn't cover it in the course, I won't include it. But this should serve as a good review for Chapter 2. And what we're asked for number 1 is, for this graph, determine values of f. Now for letter A, they're saying f is a -3. Well, this would be our x value. So the technique we said for something like that is to put that x value, remember this is written f of x, but here it's saying our x value is a -3, so we're going to have to change that, all right. So where is x a -3? Well, 1, 2, 3, right there. And we see our x value, our y value there is a 1. Okay, that's better. Again, you have to be careful. We did the right concept, but I put the wrong number there. All right, then they're asking, what is the domain of this function that we have shown here? Well, remember, domain are our x values. So let's look at our graph. Our x values start right there, and they go up to right there. So in interval notation, our domain will start at -4, using a bracket to indicate it's part of the set, and goes up to a 3. And in set builder notation, we can do that one too. It would be x is such that -4 is less than or equal to x is less than or equal to 3. So a couple of things that we've done throughout this term. Now for letter C, they're saying any x value for which f of x equals 3. Well, remember we said f of x could be replaced with a y equals 3. So now we're going to put a 3 over here. That's what y equals. And when y equals 3, what does x equal? So we look on our graph, and y equals 3 right there. And our x value right there is -4. So in the first case, up in here in A, they asked what was our y value. And then in C, they're asking for our x value. They give us the y. And we pick it out from the graph. And now they're asking, what is the range of f? That is, this function. Well, range, once again, refer to the y values. So, where does y start? Well, y starts right down there, and it goes up to right there. So it's actually, in interval notation, it would be y is from -4 up to 3. And both of these are included. And in set builder notation, the only thing we have to change here is the letter y. Y is such that it's from -4 less than or equal to y less than or equal to 3. Okay, lots of stuff that we reviewed in just that first one right there. Okay, moving on to number 2. what we're asked to do here is to find the slope of this graph. And again, on the graph paper, it looks a little better, but here we see this point is going to be 5, 300. And this point's going to be 10, 600. So with these 2 points, I can put it in my slope formula, and I get 600 minus 300 over 10 minus 5, which gives me 300 over 5. So the slope of this graph is 60. And then here they're just giving us 2 points. So it'll be 6 minus 3 over 3 minus a minus 2, which makes it a plus 2. So then this gives me 3/5. This one is interesting because it's a negative 6.2 minus, a minus makes it a plus 6.2. And as soon as you see that, that numerator is a 0. So you don't even have to do the bottom. The bottom is going to be 3.5 minus 7.1. We don't care what this result is, because we know that's a 0 and this is a number other than 0. So the slope for this one is 0. And then in number 5, it's in slope-intercept form. Y equals mx plus b. So whatever is in the m position, 3/2, that's our slope. And whatever in the b position, that's our y-intercept. But we're asked to write it in the official way. So it'll be 0, 4 for our y-intercept. For number 6, this one is in standard form, and we're asked to find the slope and the y-intercept. Well, to do that, we have to put it in this form, so we're going to solve for y. 5y, transpose the x, change signs, divide everything by 5, and we get now our slope is a negative 5/3, and our y-intercept would be 0, 6/5. In this equation, it's in function form, but remember we can replace this function notation with a y. Y equals 8 is in the form of y equals b, which is a horizontal line. The slope of a horizontal line is 0. That would be what m is. Here, this is an equation in the form of x equals a. So we solve for x. X equals negative 8. What would be the slope of a vertical line? This one is undefined. So there's a couple of things that we've gone over. They've asked some test questions about, but that's what you do as you study to prepare. Now we're going into a couple of other things. It just seems like we did these. Find the intercepts. Well, here they're giving us an equation in standard form, and we said a good tool to find the intercepts was to put this special x and y intercept t-chart. So if x is 0, this becomes a 0. Our y is going to equal 6, because we're going to divide both sides by 2. Now if y is 0, we're going to divide both sides by a negative 3, and we get a negative 4. There are our intercepts. And if we were to graph that, we'd say 0, 6, 1, 2, 3, 4, 5, 6, put a dot there. Negative 4, 0, 1, 2, 3, 4, and there's our graph. And then if we were to graph this one, this is in slope-intercept form. We said the technique for that was to first graph your y-intercept, which was negative 3, a dot there. And our slope was 2 over 1, a positive. So we did the run 1, the rise 2, and then that was our graph. And here, this one is in standard form. So again, I would strongly advise the x and y intercept t-chart. If x is 0, y is going to be 3.5, or 7/2. 3.5 is a little easier to graph. And if y is 0, this is going to be 7/4, which is almost an 8. So when you graph it, 0, let me put it 1, 2, 3, 4, so halfway up this way, and then 1, 2, 8/4 would be right there, so right about there. And let's see if I can do that one. And there it is. Again, I wouldn't give you one like this. It would be more easier to do. All right, now for this one, you might recall it's in a special form. This one's in the point slope form, where it was y minus y sub 1 equals a negative, no, equals m times x minus x sub 1. And one of the things they might have said, what was the point? The slope we know is this. What was the point? Well, the point was the opposite sign of this for our y value. That would have been 2. And then opposite sign of that, that would be a negative 4. So we did some like that, where we had to try to find what was the original point, then we put it into point slope, and then we had to find the equation of it so that we can graph it. So this will be y minus 2 equals a negative 3/2 x. Now the 2 will cancel into the 4, give me a 2, so this becomes a negative 6. And then we just transpose that to put it in slope-intercept form, and that becomes a positive 2 over there. So now we have y equals a negative 3/2 x minus 4. When we add 2 here, it gives us a negative 4. Now, to graph it, 1, 2, 3, 4, a dot at 4, negative 4. Our slope is a negative 3/2. So we're going to go to the left now for our run of 2 and for our rise of 3. And then there's our graph. Okay, so again, reviewing lots of stuff there. The point slope form, how to get the coordinates, and then how to put it in slope-intercept form. And they're not asking for standard form, so we'll leave that. Now they want us to graph this. So I want to get my x positive by putting it over there. Bring that over as a negative 5. This becomes a 2. So we get x equals 2. This happens to be a vertical line at 2. I was a little off there, but close enough. As we continue, you may notice that I'm moving through this a little bit quickly. Again, I'm not teaching it here, I'm reviewing it, and that's why it's more quickly. And, you know, you can go back to the original lessons where we did the additional exercises and went through and taught it. Here we're just reviewing. So for number 15, they're asking, are these equations linear or not? Well, we said as long as the variables only had to the first power, they were linear. So A is linear and B is linear. When we went with a variable to the second power, this was not linear. For number 16, they're asking us, is this set of equations parallel, perpendicular, or neither? And this goes back to what we said, how can you figure that out? Well, we said the best way was to compare the slopes. So this is what I'm going to do here. My slope of this one is going to be 5 divided, well, it becomes 2/5. I divide both sides by 5. I don't care about the b. I just want to compare my slopes. Now here, this is going to be 2y. This becomes a positive 5x on the other side. So when I divide by 2, I get this slope is 5/2. So now I compare my slopes. And some of you will note that they are reciprocals. And if we multiplied m sub 1 times n sub 2, we get a 1. And are they parallel, perpendicular, or neither? Well, we know for sure they're not parallel because they don't have the same slopes. Is the product of these slopes a negative one? No, they're a positive one. Well, then they're not perpendicular because the product would need to be a negative one in order for them to be perpendicular. So, for number 16, it's neither. Because the slopes produce a positive one, not a negative one. They're not parallel, so it's neither. Now in this case, again, all we want to do is identify the slope. And this should be an x here. I think this should be an x. Let me check. Yes. That didn't make sense. All right, now, what is my slope? Well, it's the coefficient of x. So my slope for this one is a -2. And again, I want my slope to somehow stand out. It's the coefficient of x when it's in slope-intercept form. It's not there. This is standard form, or sort of. So I'm going to go 5y equals, transpose my negative x becomes a positive x, then divide by 5, and the second slope is 1/5. Keeping in mind there's a 1 there. We don't put the x as part of the slope. It's just the numerical coefficient. They're not the same. One's not the negative reciprocal of the other, so this is another neither. Okay. Now, for number 18, they want to find an equation in this format, function format, when we have our slope is this and our y-intercept is that. Well, that was an easy one. Our slope is -4. We have to put the x there. And then our y-intercept is -5. Now for number 19, they want us to use the slope of 3 and this single point to put in slope-intercept form. We had one a little bit like this, so let's do that. So we're going to write y minus, now our y term there is 8, so it just goes in as y minus 8. equals our slope, which is 3, times x in parentheses minus, now it's a minus 2 that goes there, so the opposite of a negative 2 makes this one a positive, and that's all they wanted for number 19. Now we could put it in slope-intercept form, but they didn't ask that there. For number 20, they want again an equation in function form when we have these two ordered pairs. Well, the first thing we have to do is find the slope of this, which I've set up to save a little time. And the slope is 1. Then we're going to use this form, and I'm going to use this set. So y minus a minus 2 makes it a plus 2, opposite sign. And then our slope is 1. I could put the 1 there, but really all I can do is just take that away, because that's what it is. And there's my x term there. And then I go y equals, transpose my 2 equals x minus 7. So when I transpose this, it becomes a negative 2 and negative 5, and there's what it is. So this wasn't really too hard a test, but lots of stuff there. Okay, there are a few on here that we didn't cover in our course, so I won't go over those right now. But these were things we did. And they're asking us to write an equation of a line that's parallel to this line and goes through this point. And then later it's going to be the same but perpendicular to this line and goes through the point. So whenever we need to do something like this, if it's parallel, we have to find the slope of that. So I'm going to transpose the 2y to the other side to make it positive, and I have 3x. Again, I don't care about the y-intercept, so I'm going to divide both sides by 2. So my slope is 3/2. So to get an equation that's going to be parallel to this, it's going to have this slope and go through this point. So now I'm going to use the point slope form. Y minus a minus 5 makes it a plus 5 equals my slope, which is 3/2 times x minus 3. And I'm going to clear parentheses. Y plus 5 equals 3/2 x minus 9/2. So this is a case where we have a little fraction here, and then when we transpose this, that's going to give it a negative 10/2. Now it became a negative 5 that I converted so I could combine it with this. So my final equation now is y equals 3/2 x minus 19/2. Now, one that's going to be perpendicular to this has to have the negative reciprocal as its slope. So, our new slope will be a negative 2/3. Because this times this is a negative 1. Those lines are perpendicular. So, we just write it in this formula. Y minus a minus 5 makes it a plus 5 equals our new slope, negative 2/3 times x minus 3. we then get y plus 5 equals a negative 2/3 x plus now a 6/3. 6/3 is going to be a 2, that's correct. So let's make that a 2. Now we transpose that, that's going to become a negative 5 on that side. So we rewrite it now, y equals a negative 2/3 x minus 3. Okay. Well, again, lots of stuff, things that we did back in chapter 2, and hopefully this is a good review for you.